What up, everyone? This is LeetCode 278, first bad version. We've done this problem in Python, but now we're doing it in C++. So anyways, you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails a quality check. Since each version is developed based on the previous version, all the subsequent versions after a bad version are also bad. Suppose you have n versions, 1 up to n. You want to find out the first bad one, which causes all the following ones to be bad. You're given an API function bool as bad version with an input of version, which returns whether the version is bad. Implement a function to find the first bad version. You should minimize the number of API calls. So yeah, we basically know that we have 1 up to n versions, and at some point we get a bad version. We have to find where the first one occurs using that API call. Okay. The way we solve this, right, we're kind of given a hint in that we have to minimize the number of API calls. So we have to be efficient in how we check this, because we can't just spam the API. Okay, so the way we're going to do this is we're going to use binary search, right? We're going to set a left pointer at the first version, a right pointer at the last version, and we're going to calculate the midpoint. And we're going to use this midpoint, pass that into the API call, and determine whether it's a good version or a bad version. And we're going to adjust our left and our right pointers accordingly, right, based on the result. Okay, so let's set our left pointer right to 1. And again, if you look at the constraints, the first version is always version 1. We can't have version 0, and these are all discrete numbers, okay? So not continuous. So we can't have version like 1.2 or something weird like that. So don't need to worry about that, okay? Now we're going to say while left is less than right, because there's always going to be a first bad version, right? We don't have an edge case where we can't have a bad version. So whenever left is equal to right, just return left, okay? Right, so just gonna return left. So let's calculate the midpoint. So we're gonna say left plus right divided by 2. Now we are in C++, so overflow is a concern when we add left and right. So we actually have to rewrite this, okay? So we don't get an overflow. So we're gonna say left plus right minus left, okay? And I mean, even if overflow is impossible, which it is in this case, but if it wasn't, you still want to always do this in a language where you can have overflow just out of habit. It's just good practice. But we're gonna say if is bad version, that's the API, right? And we want to pass it the midpoint. Okay. So now let's say we calculate, I'll do this in a comment, 1 up to n. Now let's say we get some midpoint, right? If this midpoint is a good version, this midpoint and everything to the left of it is irrelevant because we only want the first bad version. So if this midpoint is a good version, we want to set the left pointer 1 to the right of that. Okay, so this is where it's a good version. So left is mid plus 1. Okay, now if it's a bad version, we don't want to set the right pointer 1 to the left, because for all we know, this midpoint actually could be our first bad version, and the 1 to the left of that could be a good version. So we don't want to set the right pointer to the left of the midpoint. We actually want to set the right pointer to the mid. Okay, midpoint. So we're going to say right is equal to mid. Okay, and yeah, that's basically our algorithm. Pretty simple. Really, I think this problem isn't too difficult, but it is a little bit hard to come up intuitively, like that you're supposed to use a binary search. But you're given a very small hint with this last line. But yeah, it can be a little bit hard to come up with on your own, so don't feel bad. But anyways, I hope this helped, and I'll see you in the next one.